Hello everyone, welcome to a new lecture. In this video we are going to talk about faults and joints. Faults are a result of brittle deformation. If a rock is very solid and brittle and we have a stress acting on this rock, it will break. It will not flow, it will not fault, but actually it will break. And this breakage, either it is a fault or it's a joint. So what is a fault? Well, a fault is fracturing and displacement of rock strata. So if you have a rock strata and it fractures and the broken parts of this strata is displaced or moved, then that is called a fault. Just like you see here, we have this rock strata. It was fractured and then the broken parts were displaced. This one moved up, this one moved down, then this is a fault. So how many types of faults do we have? Well, we have three types. We have dip slip faults, we have strike slip faults, and we have oblique slip faults. Oblique slip faults are a fault that is both strike slip and dip slip. But what's dip slip and strike slip faults? Well, for you to understand, let me illustrate this for you. The dip and strike comes from the concept of a dipped bed. Imagine you have these stratas or these beds going into the earth at an angle. So the angle between this layer and a horizontal line, this is called a dip. Since this layer is dipping at an angle, this is called a dip. But the line where the strata intersects earth is called a strike. So this is a strike. This is dip. So if you have a fault in which movement is primarily parallel to the inclination, then that is a dip slip fault. But if you have a fault that is in this direction, meaning it is horizontal, then that is called a strike slip fault. So this is dip, this is strike. So keeping this in mind, we have dip slip faults, those faults in which movement is primarily parallel to the inclination, also called the dip of the fault surface. We have strike slip faults, those faults that have a horizontal direction when they move, and we have oblique slip faults. So let's look at each of these in more detail. Dip slip faults, we have three kinds. We have normal faults, we have reverse faults, and we have thrust faults. So let's see what each of these are. But first, you have to understand that since dip slip faults are faults where the direction of movement are at an angle, so either the broken parts will go up or down. And imagine you have someone standing in between these parts. So you have this part and you have this part, so either this one will go up or down, or this one will go up or down. What do you call these parts? Well, geologists call the upper part a hanging wall and the lower part a footwall. So in a dip slip fault, the upper part or the part that is over your head is called a hanging wall. But the part that is under your foot, it's called a footwall. This is the footwall and this is the hanging wall. And depending whether the hanging wall will go up or down or the footwall will go up or down, we have three types of dip slip faults, as I showed you. We have normal faults, we have reverse faults, and we have thrust faults. They all depend whether the hanging wall or the footwall go up or down relative to each other. So let's look at the first one, normal faults. What is a normal fault? Well, a normal fault is a fault where the hanging wall moves down relative to the foot wall. So you see in this case, this is our foot wall, because if we stand right here, this will be under our feet and this will be over our head. In normal fault, the hanging wall moves down. As you see, the hanging wall, the part that is over our head, moves down, while the foot wall goes up. So foot wall goes up, hanging wall goes down in normal faults. As you can see in this picture, the foot wall went up and the hanging wall went down, because if you stand right here, this part will be over your head and this part will be under your feet. This part went up and this part went down. As you can see, this strata is right here and this strata is right there. So this one went down and this one went up. This is called a normal fault. But what happens when you get a series of these normal faults in a row? What I mean is just like this. Imagine you have stratas like this, and they get pulled from both sides. Where you get is strata will get broken into parts, and you get a series of normal faults. You see all of them. The hanging wall moved down here, the hanging wall right here, it moved down, the hanging wall here moved down, the hanging wall here moved down. This is a series of normal faults. This has a special name in geology, and it is called horsts and grabens. So due to the tensional stress, normal faults are created in a series. In such a case, the down dropped blocks form grabens and the uplifted blocks form horsts. So this is a horst, this is a graben, and usually you can see them in mountain range. When you have tensional stress, you get parts or you get areas that get depressed, and those areas are called grabens, and you get areas that get uplifted. Those areas are called horsts, just like in this picture. Okay, but if you notice, graben and horst, we have faults in two sides. We have a fault right here and we have a fault right there. Both of them are normal faults. What happens if you have faults only in one side? What is that called? Well, that is called a half graben. Half graben are a geological structure where it is bounded by fault from one side. Since this side does not have any faults, only this side has a normal fault, this side will go up and the hanging wall will go down. This is called a half graben. Since you don't have any normal fault on the other side for the footwall to go up and this hanging wall to go down. So we have half grabens where the structure is bounded by fault from one side, and we have horsts and grabens where the structure has multiple normal faults and the depressed parts are called grabens and the uplifted parts are called horsts. Okay, so this is about normal faults where the hanging wall moves down and the footwall goes up. But what happens if the exact opposite occurs, meaning the hanging wall goes up and the footwall goes down? Well, we get something that is called a reverse fault. So what is a reverse fault? Well, a reverse fault is a fault where the hanging wall moves up relative to the footwall. So just like you see in this picture, if you stand right here, this will be your hanging wall and this part went up while the other part went down. So in such a case, we call this fault a reverse fault. So as you can see right here, this is our hanging wall, because if you stand right here, this will be over your head and this will be under your feet. So since this part went up, you see this strata, it went up relative to this strata since it was broken. This part went up while this part went down. Since the hanging wall went up, then this is a reverse fault. The last type of diff slip faults that we have is called a thrust fault. So what is a thrust fault? Well, a thrust fault is a type of reverse fault having dips less than 45 degrees. So thrust faults are reverse faults, but thrust faults, the angle of the fault is less than 45 degrees. So just like you see here, this is the fault line and this side went up, this side went down. In reverse faults, the hanging wall goes up while the footwall goes down, but the angle of the fault is less than 45 degrees. So now let's look at strike slip faults. Well, what is a strike slip fault? Well, strike slip faults are faults in which the dominance displacement is horizontal. So as you can see in this aerial photo, we had these bits, but these bits had a fault in between and they moved horizontally. If you stand right here, this part went left while this part went right. So if you stand right here, this part displaced to the left while this part displaced to the right. This is an example of aftermath of strike slip faults. You see the displacement happened horizontally. It wasn't at an angle, but actually horizontally. If you stand right here, this side went to the right. The movement in the fault was horizontal. In other words, it was strike slip faults. This side went to right and this side went to left, or it stayed the same. So strike slip faults are those faults in which the dominant displacement is horizontal. We have two types of strike slip faults. We have left lateral strike slip faults and we have right lateral strike slip faults. In this case, if you stand right here, this will be a left lateral strike slip fault because this side went to left. It's the same if you stand right here. If you stand right here, your left side went to left. Therefore, this is a left lateral strike slip fault. However, in this case, this is a right lateral strike slip fault, because if you stand right here on this side has moved to the right. And if you stand right here, this side has moved to the right. So this is a right lateral strike slip fault. The last type of fault that we have is oblique slip faults. So what is an oblique slip fault? Well, oblique slip faults are faults that exhibit both dip slip and strike slip movement. So we had strike slip faults, we had dip slip faults, and we have oblique slip faults. And now talking about something else, and that is evidence of movement of faults. What type of evidence we have on movements on a fault? Well, we have few. We have something that is called fault breccias, slickensides, or mylonites. These are evidence of movement on a fault. The first one, fault breccias, are crumbled up rocks consisting of angular fragments that were formed as a result of grinding and crushing movement along a fault. So imagine you have a fault, either a strike slip fault or a dip slip fault. When the parts move on each other, they create crumbled rocks consisting of angular fragments that are formed as a result of grinding and crushing movement along the fault. Slickensides are scratch marks that are left on the fault plane as one block moves relative to the other. So, beside of crushing and grinding rocks, creating angular fragments, we have scratch marks that are on the fault plane that are called slickensides. When the blocks move relative to each other, they create these scratches. And finally, mylonites are ductile deformation along the fault due to dynamic metamorphism. We have talked about this in previous videos. We have talked about dynamic metamorphism and how in a region where a fault exists, when movement in this fault occurs due to the high pressure creating high temperature, we have ductile deformation and we call it mylonite. Since we have ductile deformation, this is an evidence of movement on the fault. But what if no movement occurs? Well, that is our last slide and we call that a joint. So what is a joint? Well, a joint is fractures along which no displacement has occurred. In joints, we don't have any movement. As you can see in this picture, there are fractures in the rock, but there is no apparent displacement. Just like here or there is no displacement in the broken parts of the fractured rock. So joints, we have no displacement, but faults, we have displacement in the fractured rock. And with this, we come to the end of our lecture. So to recap,